All right. So a couple things off the top before we get started. Um, the quiz yesterday, I think I kind of mentioned at the end, the wrong answer was selected. I updated everything so that it should have given credit to anyone just for answering that last question. So those should be all kind of reflected in the grade book. You initially saw that you got that last one wrong based off the answer I told you in class. I kind of have it set so it's correct now. So when you review for the upcoming exam, you'll kind of have that correct answer to kind of review. With that in mind, we will finish module 4 material today. So we'll kind of finish the material in the slides. We've got this Excel example that we'll work through. We'll also have today's participation quiz, which I'll kind of make available now. We'll get to that later on in class. And wanted to mention tomorrow we'll just be doing review. So that practice exam, if you haven't taken a look at it yet, or if you have, tomorrow I'll kind of ask people 4 questions and review the questions that I get. So kind of bring those ones that you're having difficulty with or you want to see work through, and I'll kind of start with those. Otherwise, I'll kind of pick and choose. I doubt we'll have time to work through all of them, but we should be able to get a pretty good majority of them in. And I'll add some things in that I think might be helpful for that exam. So tomorrow's review class, definitely a good one to be at. You can, if you're not able to make it live, making sure you watch it before the exam, which is going to be available on Thursday from 11:15 to 3:15. Right. So you have a little bit of flexibility in when you sit down and take it. Once you sit down and take it and start it, you'll have an hour and 15 minutes to complete it. It's 25 multiple choice questions. I'll go over all this tomorrow as well. Because we have that exam, it makes it so that there's a little bit of a quick turnaround, and I'll make this available after class today. We've also got this module 4 quiz, so that'll be available after lecture today, due before the end of the day tomorrow, as well as the module 3 quiz if you haven't done that already. And then those participation quizzes are all due by the end of the day tomorrow as well. So unlike that first week where you kind of had until the end of the day Sunday, because we have this exam, everything's going to be due before it, the day right before the exam, which is tomorrow. So a little bit of quicker turnaround this module 4 quiz. If you're reviewing those practice problems, I'll have office hours tomorrow as well from 12:30 to 1, which I put an announcement up yesterday. I kind of mentioned that was kind of, oh, did I not? I must not have done it for this section. So as I'm talking, I'll do that right now. So here, make sure that you've got, a 1 hour and 15 time block in that 4-hour time period from 11:15 to 3:15 set aside so you can get on and get that exam taken. To have the full hour and 15 minutes, that means you'll need to start at no later than 2 o'clock, which is our usual class meeting time, so that shouldn't be a problem. Okay. Any other questions logistically before we hop into material today? I believe we left off on slide 21. Okay. No questions? All right. So, I know what I wanted to do. Instead of jumping in material, let's go through those questions that we had yesterday. I want to work through a few of them since we didn't have time to, just to kind of remind us of what we talked about last class, because we'll use a lot of it today as well. So the very first question was simply, how do we calculate an elasticity of demand? Okay, so we're given a percentage change in the price of a good. We're then told the responding or the corresponding quantity demanded percent change. Is demand elastic, inelastic, unit elastic? So from last class, we remember the elasticity of demand measures the responsiveness of quantity demanded to a initial change in price. So the initial thing that's changing always goes in our denominator. We'll talk about some different elasticities later on today. The thing that is responding goes in our numerator. So here we were told that the percent change in price was 24%. The resulting change in the quantity demanded was that it went down by 15%. Take the absolute value here. I don't know what this works off exactly to be off the top of my head. I think it's, if I'm remembering correctly, rounds to 0.45. Notice there's a negative sign, but when we take the absolute value, When we're talking about the price elasticity of demand, we just care about its magnitude. So we kind of ignore that negative sign. So with 0.45, if our elasticity of demand is less than 1, that would mean that percent change in the quantity demanded was less than the initial percentage change in price. We would say people are not being very responsive to that price change. Okay, so that was the idea. If I'm not responsive, inelastic, equal to 1. We said that was unit elastic. The only way it's equal to 1 is if that percentage change in price is exactly the same as the percent change in the quantity demanded. And then if it's greater than 1, there we would say it's elastic because that percent change in quantity demanded would have to be larger than that percentage change in price. Okay. So that one shouldn't be too bad, just kind of reminding us what we talked about. If instead I had an example where I'm having a local gym, they change their membership fee from $20 to $30, so they're increasing the price. As a result, the number of memberships they sell, or the quantity demanded, is going from 120 to 100. And this one must not be 0.45. I was thinking about a separate one. So what was that? 15 over 24, 0.62. So still inelastic, but sorry, slightly different value. I was thinking about problem 2. So we kind of already know what the answer is, but we'll kind of see how would I arrive at that. Okay. So we said this elasticity of demand is the percentage change in our quantity demanded in response to a percentage change in price. How do we find percent changes? We said the way we find a percentage change using that midpoint method would be I take my new quantity minus the old quantity, so just that change in my quantity demanded, and I divide it by the average quantity demanded. Well, the average of two numbers would simply be adding those up and dividing by 2. Okay. I would do the exact same thing for my denominator. I'm going to take the change in price and then divide it by the average of those two prices. So this is our kind of general form of our midpoint method to calculate the price elasticity of demand. From here, it's just a matter of plugging in our values, right? So we had what? The new quantity, I think, was 100 minus the old quantity of 120. I can do the math here. I can look at the average. It's going to be what, 110? And then the change in the price was going from what? 20 to 30. The average of those two would be 25. Now you can plug all those numbers in to get those averages. I'm just kind of shorthanding this for the sake of time. If I work this out, I think I end up getting 0.45. So once again, we have another example where gym memberships here must be, well, if this is less than 1, we would say that that demand is inelastic. Okay. Excuse me. And then which of the following is going to be true about a perfectly elastic demand curve? Well, remember we said if something is perfectly elastic, maybe one way you can kind of help remind yourself, is it a vertical or a completely horizontal curve? So we have perfectly inelastic or perfectly elastic, that was horizontal and vertical curves. So instead, I would think about something that's really close to perfectly elastic, right? So something that would be very elastic or responsive would mean I could see a really small change in the price and people are going to buy a lot more. So maybe initially they're buying this much. When I lower the price a little bit, they respond by buying a lot more of this good, right? Or a large percentage change. So what would that look like? Oh yeah, that's a pretty flat slope. Now, so that would be something that's very elastic. So what would perfectly elastic be? A completely horizontal curve, right? Completely flat. Anytime I have a flat curve on a graph, my slope would be 0. And you can remind yourself of this, here, the price is staying the same. So if I'm calculating slope, that's the change in my y over the change in the x. So here, 0 over any number above 0, my slope is 0. Now, when it comes to our elasticity of demand, that was our percentage change in the quantity demanded in our numerator, percentage change in the price in our denominator. So here, when the price is not changing, so there's no percent change in the price, we still see that the quantity demanded can change. Any number over 0 will give us this elasticity of infinity. Okay. So when we're thinking about which of the following is true about a perfectly elastic demand curve, it has a slope of 0, but its elasticity of demand would be infinite. So that one's not true. It's completely horizontal, so that's not true. And then we know that it means it's very responsive. So not being very responsive, that one's not true either. So we only had one kind of solution there. And then some of the things that we talked about that just makes a good more or less elastic in terms of consumers' demand. Basically, if I have substitutes, I can be more, I'm more likely to substitute away from something that increases the price. So if I have more substitutes, I can be more elastic. If I have more time, I can find more substitutes. So these first two don't make sense, right? If I have fewer substitutes or less time, I have to pay whatever the price is. So I can't be responsive. So I would be actually more inelastic from these two. If something is a greater proportion of someone's income, we said they're going to focus a lot more on getting a good deal, right? Really be concerned with the price. And so they're going to be really responsive to price changes. That would make them more elastic. Okay. And then a product having a relatively low price, we'll work through some examples today where we see that this one actually would make it more inelastic as well. So we'll kind of talk more about today why we could rule out this fourth option. Okay. Any questions over any of those questions before we jump back into the slides here? Okay. So we talked about this last class, and I just kind of revisit it in this perfectly elastic example. We said the slope is 0, the elasticity of demand would be infinite. So they're not the same thing, but they are related. So with a linear demand curve, slope is always the same. We could choose any 2 points on the demand curve, and we would calculate the slope, we would come up with the same value. However, we've up to this point talked about like different goods being elastic or inelastic. But the truth is, even if we look at the same good, if we're at different points on the demand curve, we can actually see that the elasticity of different points on the same demand curve will actually be different. Okay? And as a general rule of thumb, as we look at lower prices and higher quantities, or we move down the demand curve, our elasticity actually decreases, or that good is becoming more inelastic, right? So I've got an example here, but I'll use some extreme numbers, I think, to really help prove to you. So you don't have to take me at my word that that's going to be true. That if we're looking at something like this, okay. So let's say I got my demand curve, and let's say initially, here's the price of 0, quantity demanded would be, price of 100, quantity demanded is 0. If the price is lowered to 99, they would increase the quantity by to 1. Now, I'm not going to use the midpoint method here, just for the sake of kind of limiting how much calculations we have to do. But hopefully you can kind of see, if we use the midpoint method, it would be a very similar thing. And when I go to a future example. So if I start at 100, decreasing the price by $1, not using the midpoint method, if I'm thinking about my elasticity of demand, that's the percent change in our quantity demanded over our percentage change in price. So going from 199, a $1 decrease would be about what? A 1% reduction in price. Going from 0 to 1, in fact, this is going to be like starting at 0, if I don't use the midpoint method, this is like an infinite change in our elasticity of demand. I won't use infinite, I won't use infinity here, but I'll just use like a really large, right, change. If I'm doing the midpoint method, I think I actually end up with 200% here. Hold on. All right. So I would have an elasticity that's definitely greater than 1, or, right, 200, right? So I'm going to have very elastic demand when prices are high. Because when prices are high, any change in price is going to be a small percent change. And starting at 0, any change in the quantity demand is going to be a large percent change. So I would always end up with a fraction above 1, or I'd have elastic demand. On the flip side, let's think about if I'm going from 1, selling 99 units, and at a price of 0, I would sell 100. Well, now, what's my elasticity of demand, right? That same $1 decrease in price is a very large percent change, right? So here, if I use that midpoint method, I'm getting same kind of idea, about a 200% decrease in the price. And once again, this is going to be a 1 unit increase in quantity would be about a 1% increase. So this fraction is going to definitely be way less than 1. In fact, it's close to 0. So down here on this portion of my demand curve, the demand curve is inelastic. The slope is the same at any point, but at higher points on my demand curve, it's more elastic. Lower points on my demand curve, it is inelastic. So as a general rule of thumb, as we move down this demand curve, demand is becoming more inelastic. Okay. And I've got some examples where we actually can kind of prove this with some other numbers as well. Right? So here's another set of numbers. We can see this, and here I will use the midpoint method. I just won't write every single thing out, but that's where these values will come from. So I think about moving from a price of 30 to 20. Well, that same $10, right? I'm seeing a $10 decrease in the price, convinces consumers to buy 20 more units of this product. So if I use the midpoint method, this is a 200% change in my price. The change in the quantity demanded would be 40. So how am I doing that, right? I'm just taking the change in price of 10, right? Dividing it by the average price of 25. That's where I'm getting that 40%. Now, if I do the intermediate calculations, we said I'll actually end up with what? 10 over 25 is 0.4. So it'll be in decimal form. So I'm writing it in terms of percentages here. But if you were to kind of do this calculation, you would find 0.4 here in your denominator. What's that midpoint method for the percent change in the quantity demanded? Well, I'm going from 0 to 20. So that change is 20 units divided by the average of these two numbers, which is 10. 20 over 10 would be 2. As a percentage, 200%. So notice here, when prices are high, I have elastic demand, right? Now, if I see that same $10 decrease, but I'm moving from $20 to 10 as the price, using the midpoint method, once again, that change in price is still 10, but now the average of these two numbers would be what? 15. So 10 over 15 would actually be a 67% decrease in price. And then the corresponding percentage change in the quantity demanded, if I use 20 and 40, would be also a 67% increase in the quantity demanded. So for the middle portion of my demand curve, demand becomes unit elastic. And then if I were to use these 2 points, if I move from a price of 10 to 0, the percentage change in my price is 200%, percent change in the quantity demanded 40. Now I've got demand that's inelastic. Okay. So any demand curve, you can use the values. Now, there's obviously not just 3 kind of portions. Like I could find the elasticity between 10 and 9 and 9 and 8. What's going to be true as I find the elasticity for lower and lower parts of this demand curve, that elasticity should be getting closer and closer to 0, more and more inelastic. Okay. Any questions there before we keep moving? So we're next going to talk about, now that we know the elasticity of demand is getting, of the same demand curve, is getting lower or getting closer to 0, more inelastic as we go further and further down the demand curve, we're going to think about what do companies want to do, right? In terms of, do I want to increase or decrease the price of my product? Well, we said last class, companies like inelastic products because that means I can increase the price and people don't stop buying that much, right? They buy a little bit less, but not that much less. So this kind of relationship of elasticity and total revenues is what we're now going to dive into. So to do that, we have this idea about the elasticity of our demand curve. We're also going to use this equation, which total revenue is simply the price of the good that I'm selling times the number of units I can sell, right? So we're going to use this equation for total revenue to then think about, okay, if I have elastic or inelastic demand, do I want to increase or decrease the price? Okay. So I'll show you some numbers first, and then I'll kind of do a more general using some arrows to kind of think about this relationship. So here I've got a demand curve, and I just rearranged it so you can think about if I have price as a function of quantity demanded, I can write quantity demanded as a function of price just by rearranging it a little bit. So at a price of $5, how many units do people want to buy? 5 minus 5 would be 0. At a price of $4, How many units will people buy? 5 minus 4 is 1, so on and so forth. So I have these different price and quantity demanded combinations. This would be like my demand schedule. How would I find total revenue? That's just price times quantity. So 5 times 0 is 0, 4 times 1 is 4, 3 times 2 is 6, 2 times 3 is 6, etc. So I've used the midpoint method here, and then I've kind of written things out in terms of percentages. So initially, when prices are high, the percentage change in price, so it's the same $1 decrease, but that's going to be a smaller percentage change than when I'm down here, where a $1 decrease would be a very large percentage change in the price. So here's my percent change in the price and the corresponding percentage change in my quantity demanded. Initially, when quantity is low, that same 1 unit increase is a very large percentage change. When quantities start to get higher, that same 1 unit increase is a much smaller percentage change. So I calculated the elasticities here. I left them negative. I really should have taken the negative sign off here. In fact, I'll do that right now, right? Because we really should be taking the absolute value to make this a little bit easier to think about. So initially, demand is very elastic. So notice when I first start to decrease the price, when demand is elastic, something above 1, what's happening to my total revenue? So I move from 5 to 4, my total revenues are going up. If I then raise the price from 4 to 3, demand is still elastic, total revenues are going up. Now notice, when demand is more elastic, how much did total revenues go up by when I lowered the price by $1? They went up by $4. Now when it's a little bit less elastic, but still elastic, when I lower the price by $1, total revenues are still going up, but only by $2. If I then kind of continue, I'll notice at that unit elastic point, or unitary elastic point, well, there if I change the price, my total revenues actually don't change at all. When demand is unit elastic, changes in the price on that portion of the demand curve won't change my total revenues. Now, once demand becomes inelastic, less than 1, now if I lower the price, notice what's happening to my total revenues. Now they start to decrease. Okay. So this is the actual math, the calculations of elasticity and total revenue that shows us when demand is elastic, lowering the price will actually increase total revenues. When it's inelastic, lowering the price will actually decrease my total revenues. And this will be true about any linear, well, let's get this out of the way here, any linear demand equation. Okay, so we'll come back to the movie ticket example. I've kind of got just some summary, but I'm going to draw out a graph for you before we're going to get to this trade-off idea. Well, we'll do it this way first. I'm actually going to do this a little bit different order. So when we're selling a product, right, we just said from these numbers, when it's elastic, lowering the price actually increases my total revenues. So why? Well, when I'm selling it at a lower price, I'm making less per unit. But if I'm compensating for that by selling more units, potentially lowering that price could increase total revenues. So when demand is elastic, I know that a small price change is going to cause a large number of units, additional units to be sold, or a huge increase in the percent change in the quantity demanded. Okay. So I'll kind of show you a visual of this, and then I've got another thing that I'll draw out for you. So let's say we've got this example. I'm using those values from that table, prices from 5 to 0, corresponding quantity demanded from 0 to 5. So I've got lattes here, right? Let's think about if I start out initially setting a price of $4, what would my total revenue be? Well, I'd sell 1 unit. 1 times 4 would be $4. That's my total revenue. We said on this portion of the demand curve, we had demand was, right, at $4 elastic. So if I lower the price, if demand is elastic, it should increase total revenues. Why? Well, because if I go from 4 to 3 at a price of 3, how many units am I now selling? 2. So I lost $1 on that first unit that I was selling before because I'm no longer selling it for $4, I'm only selling it for 3. However, I've convinced the consumer to buy a second unit, which I'm making $3 off of. So my net gain here, I've increased total revenues by $2. right? If we go back to that table, it was going from 4 to 6. Now, when I'm on the unit elastic portion of my demand curve, if I lower the price there, we said total revenues shouldn't change at all. Why? Because when I lower the price, I'm making one less dollar on each unit, but I exactly compensated for that by at this new price, I convinced the consumer to buy one more unit, in which I made $2. Okay. So there, even though I was selling each unit for less, right? I made $1 less per unit. I'm selling an additional unit, and these equally offset each other. Total revenues won't change. Then when it's inelastic, so on the lower portion of the demand curve, well, now if I continue to lower the price, we'll see that, oh, I'm making one less dollar on each unit, and I'm only convincing them to buy one more unit, but I'm selling it at a price of 1, so I'm only making $1. There, I'd have a net loss of $2, right, or a net gain of -2. So there, if I lower the price on the inelastic portion of my demand curve, I'm just decreasing my total revenues. Okay. So really, this idea between how elasticity is impacting my total revenues, there's a trade-off. When I lower the price, I'm making less per unit, but if I'm selling more units, I'm making some money there. The problem is when demand is inelastic, lowering the price, right, making less per unit, consumers aren't very responsive to that, so they don't buy that much more, right? And that in that case, if I lower the price and it's inelastic, I end up with a loss of total revenue. Okay. So I'll draw something out that's a little bit more continuous looking than just kind of this little toy example with only 5 points. So I would kind of draw, if you have a question talking about elasticities and total revenue, I would draw something that looks like this. Okay. So I've got price and quantity on my, excuse me, X and Y axis here. Here's my demand curve. I'm then going to think about at each one of these quantities, right? Can I map out what total revenue would be? So initially, we said the top part of our demand curve is elastic. Okay. In fact, I'll use colors here. So when demand is elastic, right, what does that imply? Well, if our elasticity of demand was the percentage change in the quantity demanded over my percentage change in price, an absolute value, we said if it's elastic, this is greater than 1, which would imply that percent change in my quantity demanded is greater than the percentage change in price. That's the only way that fraction is above 1. Okay. So if I think about total revenue being price times quantity, if I lower the price here, okay, so I lower the price a little bit, if people are very responsive, that reduction in price will result in an even larger increase in the amount of units purchased, or the larger percent change in the quantity demanded. So if this is going to drive my total revenues down, but I'm getting a larger change in quantity that's going to drive my total revenues up, what's the total effect? My total revenues will be going up here. So for every quantity here, as I'm lowering the price, right, I'm selling more units, and that's resulting in my total revenue going up. Okay. So for all of these units and their corresponding prices, as I lower the price, sell more units when demand is elastic, I know that my total revenue should be going up. Okay. When I'm down here, right, we said we're on the inelastic portion of our demand curve. Well, if my elasticity is less than 1, that would imply the denominator is actually larger than my numerator. So when I'm thinking about total revenues now, if I'm lowering the price and I'm on the inelastic portion of my demand curve, I could lower the price by a lot. And if people are really inelastic, that might result in only a small percent change in the quantity demanded. Which of these is going to be larger? That change in price. So my total revenues, the total effect would be that they go down. So here, for all of these quantities and their corresponding prices, when demand is inelastic, lowering the price is going to cause my total revenues to decrease. And then I'm drawing it bigger than it probably is, but when it's unit elastic, what we said there, total revenues don't change if I change the price. If I can lower the price or increase, if I'm on the unit elastic portion, that's where my total revenues don't change or where they would be maximized, right? Why? Well, total revenue is price times quantity. If it's unit elastic, these would be the exact same. So they would equally offset. My total revenues don't change at all. Okay. So you can prove it to yourself using the numbers that we looked at, or reminding yourself, okay, what is total revenue, price times quantity? What does it mean for demand to be elastic or inelastic? It tells us something about the relationship of these percent changes in the two components that make up total revenue. So we know that when we're on the elastic portion, decreasing the price will increase total revenues. When I'm on the inelastic portion, decreasing the price will decrease total revenues. Okay. So no matter what I'm doing, what do I want? So, well, this is kind of support for why that relationship exists. Here's what I would be able to draw if I were you when it comes to the exam. And I'll draw it a little smaller so we can kind of see everything. I would just be able to very quickly say, okay, look, I know the relationship here between price, quantity, that when demand is elastic and the lower portion of the demand curve is inelastic, right? Here's kind of at every quantity, the corresponding total revenue. So if I'm on the elastic portion, how can I get to this point where total revenue is maximized? If I'm a company, that's what I want, right? I want to generate, right? If I'm not, thinking about I can keep my costs the same here. We'll combine the two things later on in the semester. But for now, just thinking about how do I maximize my total revenues? Well, if my demand is elastic, I want to lower the price, right? I want to move towards this unit elastic point because that's where the point of the demand curve where my total revenues are maximized. So in practice, it's likely not like a range. It would be like two specific prices and quantity combinations. And then if I'm on the inelastic portion, well, what do I want to do there to increase total revenues? I want to move towards that unit elastic point. How do I do that? When demand is inelastic, I would actually increase my prices. Okay. So another kind of thing you could have written out just to kind of help you remember this. When demand is elastic, increasing prices will decrease total revenues, right? So if I increase price when it's elastic, that would decrease my total revenues. Or said differently, lowering the price will increase my total revenues. When demand is inelastic, I want to move towards that unit elastic point. So how would I increase total revenues there? I'd increase the price, right? If I lower the price when demand is inelastic, well, there I'd actually be lowering my total revenues. Okay. Any questions on anything there before we keep moving? Nothing in the chat. Okay. All right. So we'll go to our example then that I have in Excel. So this is just the Excel file that's up there on Canvas under module 4. I think it says what is it called? Movie elasticity example movie or something like that. So I had a bunch of data that I found from every year, and it was what? The number of tickets sold, the average ticket price for movies. Excuse me. Now I'm going to use the years 2018-19 because there's some goofy stuff going on with COVID. But if I have 2 points, I've got 2 different prices, 2 different quantity demanded. Now it's a very small average change in price, but it doesn't matter. As long as there's a change, I can calculate the elasticity of demand. So what I did here was just using Excel and my cell references. So once again, if you're not super familiar with Excel, you can just think of, I'm basically just clicking on the cell where I want to use that value. So I'll take my new quantity demanded, tickets sold, minus the old quantity demanded, right? And then divide that by the average of the two. Okay. So if I go ahead and do that, right? In fact, make sure my shouldn't matter, but yeah, it does. Hold on. Need to make sure my parentheses were around there. There we go. So we've got, make sure I had my parentheses so we're getting the right values here. It won't really, shouldn't matter either way. Yeah, I was gonna say, I think the order of operations, yeah, that shouldn't matter. So don't worry about that. You can actually undo that. Okay? But the thing I wanted to highlight here is when I do the intermediate calculations for that percentage change in quantity demanded, I did the same thing for price, change in price over the average price. This is going to give me the decimal form of the percentage change. So if I just wanted to be able to talk about it a little bit, oops, easier, I could just multiply that by 100, multiply this one by 100. So I could see that from the time period 2018 to 2019, there was a 0.13% change in the price, right? A very small percentage change in the price. And the resulting quantity demanded went down. So that's good, follows our law of demand here. It went down by 1.63%. So the percentage change in price was much lower than the percent change in the quantity demanded. If I then calculate my elasticity, right? Here was my numerator value, here's my denominator. I'll end up with a very elastic demand for movie theater tickets. And in fact, probably to be a little bit better here, I could use the absolute value function. So I'm just dropping the negative sign, so it kind of lines up more with what we were talking about in class, where we always look at the absolute value. If you look at like an academic paper, typically you'll see the price elasticity of demand. They still keep the negative sign on it. I just think it makes it harder when we're talking about ranges. So that's why, for the sake of this course, we always just look at the absolute value. So here, I've got that demand is very elastic, right? So what should, if I have elastic demand, if I increase the price, what should that have done to my total revenues? Well, if we go back to our total revenue here, right? If I'm on the elastic portion and I increase the price, that should actually lower total revenues. Sure enough, when they increased the price and demand was elastic, my total revenues went, or my total box office, or even after they adjusted for inflation, went down. So, I don't know what was the movie theater industry thinking here? I don't know. They should have, been able to determine that we're on an elastic portion of our demand curve here. Increasing prices is just going to lower our total revenue. Okay. Now, this is all well and good, and I'm really kind of being not super responsible in just kind of calculating this from yearly data, because one thing that we do in this class is we said we're trying to get causal relationships, cause and effect. We're always holding everything else constant. There's a lot of other things changing here, right, that we're not able to hold constant. So this is a good example because it matches up with the things that we were talking about. But in practice, could we actually look at every single point here and think about this is actually the same demand curve? Well, no, right? So in fact, if you go to an older time period and you see here that, oh wait, at the lower prices, demand was actually even more elastic, that doesn't match up with what we were talking about. Well, the reason why is because this is actually a different demand curve. There were factors in 2013 that are not the same as 2019, and so we're looking at an entirely different demand curve. So we're talking about calculating elasticities on the same demand curve. We're assuming everything else is held constant, so we really can't look across time. We would have to look at within a very short time frame differences in prices. So it's okay to use this for an example, but we want to be a little bit careful. If we were thinking about these values, we shouldn't plot them all out to get demand, because really demand for movie theater tickets is going to be 2019 demand, 2018 demand, et cetera. It's going to look different every single year because we can't hold all these other factors constant. Okay. Any questions on that? I just thought it was kind of interesting to see maybe how you would do this with some real world data. It's not perfect because we can't hold these other factors constant. And it was a good time for me to mention, if you're going out there and gathering data to kind of reinforce some of these principles we're talking about, you really would need to be holding these other factors constant. So no questions there. Then I think what I'm going to do, we'll kind of keep going through material and we'll kind of look at that quiz at the end of class. So we've talked about different, or sorry, we've talked about one type of elasticity. We're now going to talk about different types, right? So we have the price elasticity of demand. We're also going to have the cross price elasticity of demand. So remember that word that comes first, that's the initial thing that's changing, right? So if I've got my cross price elasticity of demand, the first word is going to be what goes in my denominator. So cross price means it's a percentage change in the price of some other good Y. And then we want to know, how does the quantity demanded for good X respond to that, right? So the thing that comes second is in our numerator. The initial change is what goes in our denominator, okay? Now, if I have something, right, where the price of Y goes up, so just to put a number to it, let's say it goes up by 10%. If the amount that people buy of good X also goes up, and here I will just use the same amount just to kind of make this easy. Well, notice I've got a positive over a positive, right? What would this imply about the two goods? So when Y is more expensive, right, people are buying more of good X. That must mean people are not buying Y and substituting towards good X. So if I've got a positive over positive, or my cross price elasticity is positive, this is telling me that these are substitute goods. And you could do it the other way as well. If it went down by 10%, right, the price of good Y, more people buy good Y, they stop buying good X, well, there, negative over negative would still give me a cross price elasticity that's positive, indicating these are substitute goods. Okay. Any questions on that idea? Now, let's say I have another example where I'm still looking at a cross price elasticity of demand. But now when the price of good Y goes up, maybe people buy less of good X. So what would that mean? That when the price of this other good is going up, I'm buying less of good X. That would mean that I must be using them together. So I always use this example when I do an in-person class. I have like a clicker that I click through the slides. If all of a sudden prices of AA batteries goes way up, what happens to my demand for that clicker? It goes down because I can't use it without batteries. Right? So anytime these two things move in opposite directions, I would end up with a negative cross price elasticity, which tells me these two goods would be complements. And then same kind of idea, if the price of Y went down, price of AA batteries goes down, I'm more likely to use that clicker. And so it would actually increase the quantity demanded for good X, positive over negative, negative over positive. Both would give me this negative cross price elasticity, indicating these are complementary goods. So we don't take the absolute value when we look at cross price elasticities, because the sign tells us whether or not they're complements or substitutes. Okay? Excuse me. Any questions on that idea before we keep moving? So something that's not in the slides that I just think is will be helpful a little bit when we talk about income elasticities here in a second. But you can kind of think about, there's like 4 ranges, technically 5. We'll talk about the 5th at the very end. But if goods are substitutes or complements, right? So we said when the cross price elasticity was, oh, what do I want here? We'll do negative, right? Negative. This was telling us that they're complementary goods. So anything in between negative infinity and -1 would imply what? Well, remember, it's the percent change in the quantity demanded for good X over now the percent change in the price of good Y. So if the percentage change in the price of good Y is less than the percentage change in the quantity of good X, this fraction will be greater than 1. we would say that demand for good X is very responsive to price changes in good Y. That must mean, like in my example for batteries, I need good Y in order to use good X. So here, we can kind of think about these would be like strong complements. Now, if there's a large percent change in good Y and it doesn't really impact how much I buy of good X by that much, or I'm not very responsive to changes in the price of the other good, but the sign is still negative, so it's somewhere in between kind of 0 and -1 here, I would think about these are like weak complements. And then on the other side, right, if my elasticity, cross price elasticity of demand is greater than 0, I'd have similar ranges, right? 0 to 1, it would be like it's inelastic or a very weak substitute. And then 1 to infinity, I could think about these are strong substitutes, right? Now, what if I had a cross price elasticity of exactly 0? What would that tell me about the two goods? That when there's a change in the price of good Y, what would the resulting change in the quantity demanded for good X have to be? Well, the only way this fraction is 0 is if that numerator is 0. So that means the price of good Y is changing, doesn't impact good X at all. These would be like completely unrelated goods. Okay. So we can still determine like whether or not it's elastic or weak, right? So weak relationships would be like when it's inelastic. The strong relationships were above 1, so that was kind of elastic. But here the sign tells us about what type of relationship these two goods have. Okay. So just a different way of visualizing this. But if we've got positive cross price elasticity, substitutes, negative cross price elasticity, they'd be complements. The next thing we'll talk about is the income elasticity of demand. Right? So a very similar idea, right? If I've got my income elasticity of demand, so once again, the first word, that's what goes in your denominator. So if I have the income elasticity of demand, and here I write it out using M. That's kind of the convention, and we'll use it in subsequent chapters. Income is always in economics. We usually write M. I'll just write it out in terms of the word just to make it a little bit easier for right now. So the thing in my denominator is the initial thing that's changing. So my income is changing. So a percent change in income goes in my denominator. How is demand responding to that? Or what is the percentage change in my quantity demanded? So if income goes up, and as a result, people buy more of something, we would say that is a what? We said last class, that's a normal good. Right? Actually, not last class, I mean a couple classes ago, sorry. But it's a normal good. We've already talked about this. Same kind of idea. If my income goes down and I buy less of something, that would also reflect it's a normal good. Notice here, positive over positive, negative over negative. Anytime my income elasticity of demand is positive, I've got a normal good. Right? Now, what happens if I see an increase in income and people buy less of something? Well, that told me it was an inferior good. Or if I have less income and I end up buying more of it, that also is just the opposite way of saying this is still an inferior good. What is my income elasticity in those scenarios? Positive over negative, negative over positive. When my income elasticity is negative, that tells me that this is an inferior good. Okay. Any questions on this idea? So before I go back to the slides, I'm then going to think about two different types of normal goods. Okay. So let's say I'm looking at an income elasticity and I don't know, income goes up by 50%. And as a result, people buy 5% more of this good. So it's positive. So it's a normal good. But were people very responsive to this price change? Well, this elasticity measure would be what? 0.1. So once again, same kind of ranges that we had before. In between 0 and 1, this is like inelastic. What does inelastic mean? People aren't very responsive. Now it's not responsive to price changes, but it's that they're not very responsive to percent changes in income. So for these goods, even though they're normal, we would say when people have more money, they keep buying about the same amount. We're going to call these, let's see, I'm probably spelling this wrong, necessity goods, right? Anytime I have something where that income elasticity, let's say my income goes up by, I don't know, 50%. And as a result, I buy 200% more of this good. Well, there, it looks like we've got now kind of like elastic income elasticity of demand. What would that mean? That when people have more money, this is still a normal good, right? But they're very responsive to changes in income. So these are going to be things that we think of as luxury goods. Why? Because how do we get such a large percent change in quantity demanded typically? When we're looking at low quantities, when people are going from buying 0 to 1 of something. Okay. So the inelastic portion of the income elasticity, we would call those necessity goods. The elastic portion of the income elasticity of demand, we would call those luxury goods. Okay. So to kind of round this out right here, right? Normal goods versus inferior goods. Normal goods will be positive, inferior negative, and then we can break down that positive range into necessity and luxury goods. Okay. So necessity goods, think about things like food, gasoline, clothing. Generally, when people have more money, you still need the same amount of food to survive. You still need the same gasoline to get to and from work. Doesn't matter if you have more or less income, you need about the same amount. Now, yeah, they're normal, so you will buy a little bit more when you have more income, but you're not going to be very responsive to changes in the quantity demanded of those goods won't be very responsive to changes in income because you generally need about the same amount. And then luxury goods, once again, these are things like typically the reason why you get such a large elasticity or why it's greater than 1. I don't know why I wrote it out. That's a goofy way to write that. And here, I think, oh, yeah, there we go. Greater than 1, right? That makes a little bit more sense. And then here it's not demand. Now we're talking about income elasticity. So I'll change those slides on Canvas to make sure I'm kind of keeping that notation consistent. Typically, it's going to be things like a Rolex, new houses, Ferrari, where changing your income, yes, you're buying more, but your response going from 0 to 1 is going to be a very large percentage change. So we would call those luxury goods. Okay. Any questions on that before we keep moving here? So I put a link up to a peer-reviewed article, so you can click on it and go kind of investigate a little bit. But it's kind of interesting. I think this was talking about like food choices. So I'm talking about food as like a necessity good. And if I remember right, what they find in this paper is generally we look at food, if we measure the income or elasticities, they typically look like they are necessity goods. But if you break this down into subcategories, right? Typical staple foods like bananas, apples, rice, they look like they're necessity goods. Changes in someone's income, they don't change how much they're buying that much of these goods. Right? Now, there's some that are luxury goods, even within the same category of food, things that are like more nutrient dense or health foods. So things that are like organic bananas, right? Or, some of the other things that have like higher quality cuts of meat. Those tend to be luxury goods. So even within the same category, we might see like some types of food are necessity goods, other types are luxury goods. So I just thought it was kind of an interesting thing to kind of relate to what we're talking about in class. They investigate and kind of find basically that, right? So lower quality foods tend to be, or I shouldn't say quality, foods that make up like a part of everyone's diet, right? Generally are necessity goods, but then higher end things like nice cuts of meat, these like health, I don't know, things that have all these added nutrients in them, people tend to view those, or at least their spending habits, we see them treat those more as a luxury good. Okay. So is your income elasticity greater than 1? Because being with you is a luxury good. There's a cheesy meme to remember kind of that income elasticity being greater than 1 tells us that's a luxury good. Okay. So We've got one more type of elasticity we'll talk about, and I'll go through it kind of quick because it's really pretty easy based off what we've talked about. So the price elasticity of supply, once again, what's going to be in our denominator? The initial thing changing is the price of the good we're looking at. What are we looking at the response of, though? The supply curve. So now it's going to be the percentage change in the price in our denominator, but the percentage change in the quantity supplied in our numerator. So just like the demand curve, we could have different price elasticity of supply at different portions of that supply curve. Now, it's not going to be related to total revenues. We won't kind of do anything like that with supply. I just might expect you to kind of be able to calculate what that elasticity of supply is. It's the same way. Find those percent changes by using that midpoint method. It's going to look no different other than we don't have to worry about that pesky negative sign because we know that when prices go up, our company is going to want to produce or sell more or less, more. So this should always be a positive fraction or positive value. Same kind of ranges we have for demand. The elasticity of supply being less than 1 is inelastic, greater than 1 elastic, equal to 1 unit elastic. So nothing crazy here. Now, just like we have determinants of the elasticity of demand, we have determinants of the elasticity of supply as well. So it kind of, I think it's a little bit more intuitive even than demand. So really any flexibility that we have in the production process for supply is going to make it so we can be more responsive to price changes. So anything that makes me more flexible, I can then be more elastic or respond more to changes in price. So think about the reverse of that. Like let's say I have a production facility and the machines I have can only produce automobiles, right? Well, then if all of a sudden the price of some other goods change, I can't convert my production process over to produce, I don't know, jet skis. I can't respond to that price change. If I don't have any flexibility in my production process, I can't respond to changes in the price of other goods other than whatever my current setup is made to produce. Now, in my same example, if I have like automobiles, let's say the price of automobiles changes, goes up. If I want to produce more, well, if I was already at capacity, I can't produce any more than what my capacity is. So what do a lot of companies like to do? They like to have extra capacity just in case prices go up. They can then be responsive. They can produce more and be responsive to those price changes. Okay? Another example of this flexibility I would think about is like relocation. So think about something like automobile manufacturers. I can't just pick up and move if I'm Chevy, my main production facility to a new country or even a new area where I think prices are going to be higher. But what is something that's a good example of like being able to relocate easy and making me really responsive to price changes? If I have like a food truck and I'm thinking about all of a sudden like, oh, people in Bloomington are willing to pay more for this type of food, and I was currently selling in Indianapolis, what can I do? I can respond to that price change, go supply a lot more of whatever the food I have in my food truck is to Bloomington, right? So being able to relocate easy, I can be really responsive to price changes in different areas. So any type of flexibility in the production process makes it so we can be more responsive to price changes or more elastic. Excuse me. And then the same principle we had for demand applies to supply. If producers have more time to make supply decisions, right? So if I can project out for the next 10 years, I might be able to build my production facility somewhere where I think prices are going to be higher, right? So more time to make a decision or to adjust my production process, I can be more responsive to price changes. More time basically just means it's giving me some more flexibility in my decision making. And then less time, right? I'm not going to have as much time to adjust my manufacturing process or where I'm located. So less time is going to make me less responsive. And the same kind of thing, we had more time made demand more elastic, less time made demand less elastic. So the same thing would apply to producers here. Okay. All right. So I've got two interesting examples that kind of relate to some of these elasticities we've talked about. So the very first one is going to be a tragic example of how people maybe make decisions without thinking through the economic principles and implications that even as simple as what we're talking about in this class. So the Sudanese slave trade in the 90s, these humanitarian groups, they had good intent. They had this idea, and I think they even like raised funds. I think maybe even through churches and things. I'd have to go back and confirm. I believe this is what they were doing. And they went in and said, we're going to go buy these slaves, right, and then set them free. Sounds like a great idea. However, how would these humanitarian groups be able to purchase the slaves? They'd have to offer a price that's the highest, right? They'd have to be the winning bid. So if they go in and start giving more money than what was currently being paid for those slaves, they've increased the price. Well, if I increase the price of something, what happens to supply? It goes up. And in fact, if the demand for slavery, or sorry, if the supply for slavery is very elastic, right? If all of a sudden these humanitarian groups are coming in offering slightly higher prices, if people are really responsive to that, what happens? Then they're going to go out and enslave a lot more people. The percent change in the quantity supplied of slaves would go up by a lot. So they went in, they were increasing prices. They also saw that supply increased, but by how much? Well, it ended up being a lot. Huge percent changes, even though they weren't offering that much higher prices, just to like make sure they were kind of winning, the bid game to get these slaves and then set them free. It resulted in a huge increase in the number of slaves in terms of supply. So this is an example. I like to kind of throw in these throughout the semester. A lot of times we'll use things like bananas, chairs, automobiles, typical goods markets we would think about. We can think about a lot of other more unique markets that you might not initially think of as like being a product. Here, slavery in Sudan, you can actually think about the same market forces are at work, right? There's a supply of slaves, there's a demand for slaves if there's a price, and so we can kind of think about applying the principles that we've talked about. Okay. So did the humanitarian efforts work? No, right? They increased the price, they just increased the supply. So even though they were setting some of them free, there was now more slaves being sold, not just to the humanitarian groups, but to other people as well. Okay. All right. So the other example that I have here that I think is pretty interesting. So I clicked on the link and I'll scroll down here. Now they do some fancy stuff that we're not going to talk about. Let me see. Yeah, here we go. So we're down here at table 4, and I'll come back to this here in a second. So this paper, it's another peer-reviewed article that was published. I can't remember all the details, but basically they found like these heroin users, I guess, and gave them decisions to make in like an experimental lab on computers. And they gave them like artificial budgets and prices for 4 goods: beer, cocaine, marijuana, heroin. Said, if you had this much money, here are the prices of these different goods. How much would you buy? Right? And made them choose different amounts. Okay. So for example, they would say, if I gave you $10, or sorry, if I gave you a certain amount of money, the price was $6 for a bag of heroin, $10 for a bag of heroin, how much would you buy? They changed the quantity they bought from 4 to 2. Well, what can I calculate? I've got different prices. This is an interesting example because I can keep their income the same, right? I can keep giving them the same amount of money and just change the prices of these bags of heroin and see how much they would buy. I've got 2 prices, 2 quantity demanded. I can calculate price elasticities of demand. Now, what do we think the price elasticity of demand for heroin from heroin users probably is? Probably inelastic, right? They're probably going to use as much, they're going to want to use heroin regardless if the price is higher or not, right? And so we think that even if there's a percentage change in the price of heroin, it's not going to result in a very large decrease in the quantity demanded. So we probably have inelastic demand, right? Well, I can calculate what it is by simply plugging in, using the midpoint method, my prices, my quantities, and calculate that I've got pretty inelastic demand. So in fact, that's what, where did it go? Oh, it pulled it up in this web browser. So this is a fancy way of doing this. It's outside the scope of this class, but essentially these numbers represent the elasticity. So they run some regressions. Log price and log quantity is really just a way of looking at percent changes, not using the midpoint method. It's a slightly different method. So this is going to tell us that when the price changes, how much is the quantity, what's the response in the quantity demanded? Same ranges. Now they have the negative signs here because, well, that's, matches up with our law of demand. When price goes up, quantity demanded would go down, but it's still going to be elasticity. So anything between, in absolute terms, 0 and 1, here they kept the negative sign on it. So anything in between really 0 and -1 would be inelastic. Sure enough, they find that heroin price elasticity of demand is inelastic, okay, negative 0.7. Now, it's a little bit, I would have thought it was a lot closer to 0 than that, but, it's still inelastic, okay? Now, what they also did is they had these other 3 goods, beer, oh, where is it? We'll keep scrolling down. Beer, cocaine, and marijuana. So here, they did a very similar thing looking at cross-price elasticities. So when I look at cross-price elasticities, right, this is telling me when the price of heroin changed, did that change how much marijuana, beer, or cocaine people were using? So you can almost think about like a lawmaker saying, okay, what if we somehow legalize heroin, but tax it, increase the price? What's that going to do to the consumption of other goods? Well, for heroin and marijuana, we actually find that these have a positive cross-price elasticity, which would tell me that what? When the price of heroin goes up, people must be buying less of that and more marijuana, right? They're moving in the same direction so that these are actually substitute goods. Now, yes, it's positive, telling us they're substitute goods, but what is this really close to? 0. These are almost unrelated, right? Marijuana and heroin, almost unrelated goods. However, when you look at beer and cocaine, so for beer, once again, positive. So it looks like these are substitute goods, but actually now this is a little bit further away from 0. And something outside the scope of this class, this little star, basically means that it's statistically, there is a relationship between these two. So it's not just 0. So here we've got a cross price elasticity that's positive between heroin, the price of heroin, and beer. These are substitute goods. Okay. So interestingly enough, if we did legalize heroin and tax it, what would happen to the consumption of beer? Go up. Now, heroin prices and the quantity demanded of cocaine actually have a negative cross price elasticity. So when the price of heroin goes up, people actually use less cocaine. That must mean that these are complementary goods, right? So a negative cross price elasticity tells me these are complementary goods. I don't know, the story here must be something like when you have a good that's a downer, right? You need something to come up from it, right? So when the price of heroin is lower, people buy more heroin. They also are going to want more cocaine to kind of come up from that high, or vice versa. When the price is higher, they're not going to require as much cocaine, right? If they're using these 2 goods at the same time, right? Or they view them as complements. So not something I necessarily would have thought of ahead of time, but here we are, right? And then they also do something with income. So, they find that, where is it at? We could do income elasticities. Oh, here's my scroll bar, sorry. We go back to thinking about the price and quantity of heroin. They also look at your budget. So here it's positive, right? So higher, having more income, right? Or a higher budget means that you're going to have, consume more of this. It looks like it's a normal good, okay? So I don't know. I thought that was kind of an interesting example of the elasticities that we talked about today, kind of seeing some actual research being done discussing these elasticities. But we also want to look at, before we end class today, this participation quiz, okay? So we got a little bit of time here. We can kind of work through these, and there's really just 2 questions today. So the first is going to be, if we get this preview to pull up. Oh, come on. Did I break it? All right, well, we'll see what the answer is ahead of time. It's fine. Let's go back to here. I don't know why they got a spinning wheel of death there. Let's think about this first question, okay? Oh, I clicked on the wrong one, of course. I want today's quiz. There we go. So for today's quiz, question 1 is, if I start out, I've got prices for cigarettes, and I'm going to increase the price from $4 to $5. If the price elasticity of demand is 0.4, if I raise my prices, what's going to happen to total revenue? Okay. So to answer this question, this is one where I said, you should be able to kind of write out stacked graphs. One, where you've got the combination of prices and quantity and your demand curve. Right? The one below it is going to be your total revenue associated with selling each one of those quantities. We said we know total revenue is maximized where we've got unit elastic demand. The lower portion of our demand curve is where demand is inelastic. Upper portion is where it's elastic. What would this imply? An elasticity of demand greater than 1, and down here an elasticity of demand less, elasticity of demand at the unit point equal to 1. Okay. So we were told the elasticity of these cigarettes was 0.4. So I know I'm somewhere on that inelastic portion of my demand curve. So the question said if I raise the price from $4 to $5 here, what's going to happen to my total revenues? Well, I'm moving towards that unit elastic point, or I'm increasing my total revenues. Okay. So should be I'm increasing my total revenues by raising the price if I've got inelastic demand. Okay. Now, just to give you an example of another question, what if I instead had told you that the elasticity of demand was, I don't know, 2.3, and they still raised their price? Well, there, if I'm on the elastic portion of my demand curve, now if I raise the price, I'm moving away from that unit elastic point. What am I actually doing to my total revenues? There, I would actually be decreasing my total revenues if I had been increasing the price. Okay. Questions on that one before we do one more here? Okay. Oh, I added a copy here. Oops, just so I have it fixed for anyone else who starts it. So if, not just F, if the cross price elasticity is negative 3.2, then the two goods would be what? Substitutes or complements. And if it's negative 3.2, what's true about the relationship between the price of good Y, percent change in the price of good Y, and the percent change in the quantity demanded of good X? Okay. So with my cross price elasticity of demand, it's going to look very similar to our price elasticity of demand. It's just that now we're thinking about how does the percentage change in the price of some other good Y change that quantity demanded in good X? So I think I told you it was what? Negative 3.2. So if this is negative, that would mean that when the price of Y goes up, people actually buy less of good X. That would have to mean I'm using these two goods at the same time, or a negative cross price elasticity told me these were complements. I know that if it's 3.2 in magnitude, what's the only way this fraction is above 1 is if that percentage change in the quantity demanded for good X is greater than the percentage change in the price for good Y. Okay, so the fact that it's negative tells me they're complements. And the fact that it's above 1 tells me that percentage change in the price of good Y would be less than the percentage change in the quantity demanded of good X. Okay. Any questions on that? So we should have the kind of two answers there, correct answers. There's no correct answer. It looks like it's module 1. There's no correct answer on this. This is just a way for me to kind of gather information from you guys before tomorrow's class. So which of the following modules would you most like to see reviewed tomorrow? 1, 2, 3, or 4. Given that there's a little bit more turnaround time on 4, maybe people want to see more module 4 stuff. It's been a little bit longer since module 1 and 2. Maybe you want to see me revisit some problems there. So if I don't get any questions live from people tomorrow, I'll probably pick and choose questions from whatever category has the highest response. Okay. So no correct answer to question 3. As long as you respond, you'll get the full 2 points. And then kind of each one you get correct here, you'll get a point. So if you get these wrong, you'd still get 2 out of 4 or half credit. If you get these right, then you'll get full credit for the class, okay? Or participation quiz. All right. So if there's no more, or I'll end the recording here, but then I'll kind of leave it open if people have any additional questions.